Let's continue with our example that shows how Grasshopper can have very equivalent functionality or similar functionality to what we're using with Dynamo and Revit. Okay, so we've reopened the file that contains some different curves that we're going to use to place some elements. Okay, you might remember that we created some overall defining curves, we subdivided those, and then we used some different functions to go through and create curves that went both transversely and longitudinally. So for example, right now I'm showing the curves where we transposed the points and interpolated a curve to bring them across. That's those. Let's go ahead and kind of show you the other ones. These are more the longitudinal curves. Okay, so we have two different sets of curves that are created just by grouping the points together and creating, basically a curve between them. Now, in the Dynamo world at this point, we would take an adaptive component and we'd use those three different points which are defining this curve to place that component. And in the logic of the adaptive component, it would make sense of the notion that, between these three different points, we're going to create a reference line or a line that connects them kind of nicely. It would sort of say that the normals or the kind of perpendicular planes at the endpoints could be used to then sweep a profile along those, and that's what we do kind of within the adaptive components. Now, in the Revit world, those adaptive components are really handy because they kind of build all that into the logic of the adaptive component, so we don't have to worry about it. It's all just kind of there, and we just use the adaptive component and it does the right thing. It's a little bit harder in the Rhino world. We have to actually kind of do a little bit of that, a little more of that manually. So here's the basic logic we're going to use. What we need to do is, again, we're going to do a sweep. The sweep's kind of the basic operation we're going to do. We're going to take some sort of profile and we're going to sweep it along those curves. So as we think about it, there is a sweep operation. That's going to be okay. So we're going to sweep something along what's called a rail curve. That's the red curves that you're seeing right now. We're going to sweep that profile across there. So we need to choose a profile and then say sweep it along that. And we're going to be in pretty good shape with that. I'm going to show you we're going to need a little bit of extra logic though to kind of make it all work. So what we have to do is just connect that curve. In as the rail curves, there's a collection of them. Super. Now we need to go through and select a profile. Now, as opposed to having a predefined profile setting in the adaptive component, here we're actually just going to draw it right within the Rhino world. So for example, if I want to draw myself a little circle and use that as my component, that's my profile that I'm going to sweep along there. Super. I've created that, so what I can do is come back over to Grasshopper and say that I want to select the profile. So this profile, it's waiting to have something selected. I'm going to say set one curve and come over and choose that. And notice as soon as I choose that, over here in Rhino, that is swept. That's pretty good. Let's try sort of a different shape. So for example, this curve's kind of cool, but what if we actually deformed it a little bit? Made it more like a little square box. You can sort of see that's what that looks like. Or if you prefer a little rectangular shape instead, again, I can say set one curve, and then go through and choose that one instead. Okay, so I can basically define the curves that I want to sweep there. Okay, now the limitation of this is using this sweep, at least in this function, just it's a single uniform sweep. If we wanted to kind of do a blend between two different shapes, we need to use a slightly different function here. Because we need to have like two different profiles and kind of sweep them together. Okay. Now there's another small variation I need to warn you about here, and that has to do with basically how this profile is mapped to these different kind of curves, because you'll notice that it does a smart job. It's actually based on the shape of the rail or the direction of the rail. It's applying that profile so it's always perpendicular to that rail, and that's what we need to do. So there's a nice little group of logic here that's going to help us. Basically, what we're going to do is we need to orient the profile before we take it in. So we have the profile, that's fine. But we need to orient it. And we take a piece of geometry, and orienting it involves giving it both a plane, okay, and some distance. So what we're going to do here is we're going to evaluate basically on this curve at parameter 0. That's the beginning of the curve. So right at the beginning of the curve, we're going to evaluate really what the plane is there. So okay, what would be perpendicular to it at that point. Okay. Then what we're going to do is take the area function and use our profile. We're going to get the center point of the area, the centroid of the area. So what this orient is going to do is going to take that geometry and around that plane, okay, we're going to reorient it so that it basically follows the perpendicular frame. Okay, so we're going to reorient it so it's perpendicular. So stash that little chunk of logic away because it's going to come in useful in a lot of different cases when we need to kind of have equivalent to adaptive component functionality. So great. We're going to grab those things. We're going to just orient it and then sweep those in that direction. So in a similar way, if I wanted to have the curves going in the other direction, what I could do is, again, take these curves that are inverted the other way. I'm going to, again, pull it across. Now, this logic is already basically set up for us, so we're in pretty good shape there. We just need to go through and select the profile. So I'm going to select the profile maybe in the other direction. I'll go ahead and I'll just do my little curve profile here. So I got curves in one direction, square tubes in the other directions. But that's how you essentially get the same functionality. We'd like to use adaptive components. We don't have that, so we need to create our own little logic, which really mimics that kind of infrastructure right here. Now, I'm going to show you one other way to approach this that, again, you can use. It can be useful at times. It's a good piece of logic to know and have in your bag of tricks, in that if you have the surface, you can use the notion of the grid that we've applied to the surface to define, kind of, again, those different sweeps. What we're trying to do is basically take the lines on the grid and then apply things to that. Again, you can sort of debate about whether there's an advantage or not to going through and doing it this way, but it's just another approach that you should know about. We could take those lines and then basically try to subdivide the lines into which ones are transverse and which ones are longitudinal. And that's what's going on here. Is we're using a little bit of logic here to kind of figure out basically the vector of each of those lines and really whether it's crossing a threshold. So we're trying to figure out whether it's going longwise or crosswise there. And then based on this notion, it's going to give us true and false values about whether it is the vector is greater than a certain value, in this case 1. We're going to dispatch. That's kind of like list Boolean or filter by Boolean values. Okay, so based on that, we're going to break it into longitudinal curves or transverse curves. Once you do that, once you have it broken into longitudinal versus transverse curves, it's really the same logic back over here. Okay. But I just want to know that there's another way to do this. So if we can't just kind of quickly just define the lines by just kind of doing some subdividing and regrouping, if we have a surface and we need to figure things out, again, this is a useful chunk of logic for you to know about taking a grid, kind of decomposing the grid, and then evaluating the different lines on the grid to figure out are they greater or lesser than a threshold, and then based on that, kind of acting one way or the other way, just depending upon, in this case, applying different profiles. But it could be doing a lot of different things. So again, stash that chunk of logic away in your storehouse of tricks because we'll be using that again a little bit later.